This video is to help you complete the guided notes for Lesson 7-3, Solving Equations that have Fractions as Coefficients. Number 1, see the top of page 298 to see the method that you use to solve equations that have fractional coefficients, such as this equation here. You'll notice when you look at this equation, it's not a proportion like in the previous lesson, because on the left side of the equals, there's not a single ratio. There's actually two separate terms added together. Here is the pertinent page in the textbook. You can solve an equation with fractional coefficients by using the least common denominator of all of the fractions. Multiply both sides of the equation by this least common denominator, and then solve the resulting equation. So we have done step 1 in the notes. We see the method that the book describes. Number 2, true or false? An equation like the one in number 1 is said to have fractional coefficients because it could be written as 1/7 x plus 1/3 x is equal to 10, where the coefficient of x is this fraction and the coefficient on the other x is this fraction. This is true. Number 3, in the equation above, what is the coefficient of the first term? That's 1/7. And what is the coefficient of the second term? 1/3. Number 4, here is what we read in the textbook. To solve an equation with fractional coefficients, you multiply both sides of the equation by the LCD. Number 5, take a look at example 1a in the book, and then explain what happens if you multiply both sides by 21. Here's example 1a. Notice one denominator is 7, the other denominator is 3, therefore the LCD is 21. And you'll notice that down here the authors have multiplied the left side of the equation by 21 and multiplied the right side by 21. When multiplying the left side by 21, an expression is created with no denominators. So multiplying both sides of the equation by the LCD creates a new equation that has no fractions in it. A new equation is created that has no fractions. Number 6, look at example 1b. Explain what happens when you multiply both sides by 20. Here's example 1b on the right of the screen. We see the original equation has a fraction and another fraction, and the right side even has a fraction. Now the denominators are 5, 2, and 20. The least common denominator is the number 20. Notice that the authors multiplied the left side by 20 and multiplied the right side by 20. And when that was done, an equation is created that has no fractions in it. So in number 6, it's the same answer as the previous. The point of the method is to create a new equation that doesn't have any fractions. Now number 7, look at example 2a. The denominators are 3 and 5, so what will be the LCD? In example 2a, this denominator is 3. Later on, there's a denominator of 5, and we need to know the least common denominator. The least number that is a multiple of 3 and 5 is 15. 15 is the fifth multiple of 3, and 15 is the third multiple of 5. Least common multiples can be done on the TI-84 calculator, or they can be done manually by listing the multiples of each number. The first multiple of any number is the number itself. And then 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. Now the multiples of 5. The first multiple is the number itself. 5 times 2 is 10, and 5 times 3 is 15. Notice that 15 is the lowest number that we get to that's common for both. Number 8, true or false? To solve example 2a, you multiply all terms by the 15. That's true. The way that you solve these equations is you figure out the least common denominator so that you can then multiply by that to all terms in the equation. Number 9, show the work of multiplying by 15 and show the resulting equation. So the first thing we need to do in the blank space is copy down the example from the textbook. A is right here. We want to copy that down onto our notes. We have already figured out that the least common denominator is 15. And we're asked to multiply both sides of the equation by 15. Another way to think of that is multiply all terms of the equation by 15. Multiply the first fraction by 15. Multiply the second fraction by 15. And multiply the 2 by 15. Now we're supposed to show the resulting equation. 3 and 15 cross cancel to a 5, and so we're really going x times 5, which is 5x. Now the next term, the 5 and the 15 cancel to just a 3. So we're going to take that x plus 2 and multiply it to 3 using the distributive property, and don't lose sight of the fact that there's a minus right here. Imagine that that 3 is actually in front of the parentheses, right? In fact, we could have written it there to begin with. Then that minus sign goes with that 3. That's negative 3 times x, which is negative 3x. And it's negative 3 times 2, which is negative 6. Now on the right side, 2 times 15 is 30. So here is the resulting equation after you multiply everything by the LCD. Number 10, true or false? When you multiply both sides of the equations by the LCD, you have to multiply all terms on each side by the LCD. That is true. Now some practice problems to practice this skill. We want to solve the equation for C. This equation is not a proportion because on the left side of the equals there's two separate terms. These equations have denominators, so the technique is to figure out the LCD. There's a 10 and a 5 and a 2. The LCD is 10. 10 is a multiple of itself. 10 is also a multiple of 5, and 10 is also a multiple of 2. I want to multiply everything by 10. So 10 times the first term, 10 times the second term, and 10 times the number on the right side of the equals. Now, when we multiply these, let's make use of our canceling skills. 10 over 10 cancels out to just a 1, and so we have 1 times 3c, which is 3c. Now in the next term, 10 over 5 cancels out to a 2. And in front of the 2, there's this plus sign. So we have plus 2c. Now on the right side of the equals, the 10 over 2 cancels to a 5. And so this is 5 times 3, which is 15. We've created a new equation. It's equivalent to the original one, but it doesn't have any fractions. Now we can solve. 5c is equal to 15, so c is equal to 3. Next example. We're supposed to solve the equation for x. So you study the structure of it so that you figure out a plan for how to go about doing it. It's not a proportion because there's two separate fractions on the left side of the equals. These do have denominators. So the technique is to find the LCD. We have a 15 and a 5 and a 3. The LCD is 15. 15 is a multiple of 15. 15 is the third multiple of 5, and 15 is the fifth multiple of 3. Now that we know what the LCD is, we'll multiply all terms by 15. So 15 times the x plus 2, and 15 times the x minus 3, and 15 times the 2. By multiplying everything by 15, what will happen is canceling will occur. 15 over 15 cancels out to just a 1, and so the beginning part is x plus 2. Now, 15 over 5 reduces to a 3, and that 3 follows this minus sign, so you can think of it as negative 3, and that can be distributed to the things inside the parentheses. So negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. Now what will happen on the right side of the equals? 15 over 3 reduces to a 5, and 5 times 2 is 10. We've created an equation with no fractions. 1x minus 3x is negative 2x. 2 plus 9 makes 11. Next step, subtract 11 from both sides. Negative 2x is equal to negative 1. Next step, divide both sides by the coefficient negative 2 to get x alone. X equals 1/2. Now, question C. Solve the equation for x. Because of that 0 on the left side, we have some options. One thing we could do is subtract one of the terms from the right, causing it to move to the left side, and then we would have a proportion, which we know from the previous lesson can be solved by multiplying diagonally. Our other option is just to leave it like this and use today's technique about multiplying everything by the LCD. That's what I'm going to do. The LCD is 7. That's the only denominator in the entire problem. Let's multiply all terms by 7. 7 times 0, 7 times the 2x, and 7 times that 2x minus 8. 7 times 0 is still 0. 7 times 2x is 14x. Now, why did we times by 7? What was the purpose of timesing by 7? It was so these would cancel away, creating something without any fractions anymore. This is plus 2x minus 8. Add 8 to both sides, moving the 8 to the left side, and combine together the 14x plus the 2x, making 16x. Next, divide both sides by 16, and we will get that 1/2 is equal to x. Question D. This is an equation. It has fractions in it. So our technique is to figure out what the LCD is. One denominator is 3. The other denominator is 5. The least common multiple of 3 and 5 is the number 15. That's what we want to multiply by. We're going to multiply the first term by 15 and the next term by 15 and over here by 15. 15 over 3 reduces to a 5. Now think about what we have here. There's a 5 times to a 2 times 2, the thing in the parentheses. The 5 times 2 is like having a 10, and that can be distributed to the stuff in the parentheses. So that will be 10x minus 10. Now let's move our attention to the next part of the problem. The 15 over 5 reduces to a 3. 3 times 1 is like this just being a 3. There's also a minus sign in front that's going to go with that 3, so think of it as negative 3. and then that negative 3 will be distributed to both things in the parentheses. So negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. Now on the right side, is it still a 1 over there, or is there going to be a new number? 15 times 1 is 15. 10x take away 6x is 4x. Negative 10 plus 9 is negative 1. Add 1 to both sides. 4x equals 16. 4 times 4 equals 16. Therefore, x equals 4. This concludes the video for the guided notes. The next thing you have is an assignment on lined paper from the textbook. I have a separate video for that.